All right, this is 5.3, part 1. We're going to be looking at graphs of polynomial functions. So we've already learned a few things about polynomial functions in 5.2. We talked about how you can find the x and y intercepts. We talked about turning points, and we talked about how the turning points determine what the degree of the polynomial might be. So for example, if there are 3 turning points, then the degree is at least 4. We also talked about the end behaviors of polynomial functions and how it's dependent on the leading term of the polynomial, the term that has the highest exponent. Whatever the end behavior of that power function would be is the end behavior of the polynomial. All right, so we're going to be applying some of those things and learning a couple of other things and really diving into graphs of polynomial functions. So recall that we can find the x-intercepts or zeros of a polynomial function by factoring. So for example, find the x-intercepts here by factoring. So I have 4 terms, which means I need to use grouping to factor this. I will group the first 2 terms and the last 2 terms. Take the GCF out of each group. So the first group has a GCF of x squared. So you're factoring out the x squared. So you're left with x minus 5. The second group has a GCF of -1. Anytime there's a leading negative there, that's part of the GCF. So take out the -1, you're left with x minus 5. Once you're there, you should have 2 that match, 2 binomials that match, so that's x minus 5, and then x squared minus 1. From there, you have 2 options. You could go ahead and set those factors equal to 0 and solve for x, or you could factor that x squared minus 1 a little further, right? Because that's the difference of squares, and so to factor that, we just take the square root of each one. So that's x minus 1, x plus 1. Now the x-intercepts are going to be what you get when you set those equal to 0. So x minus 5 equals 0 gives me x equals 5. X minus 1 equals 0 gives me x equals 1. And x plus 1 equals 0 gives me x equals -1. So my 3 x-intercepts are 5, 0, 1, 0, and -1, 0. All from factoring. So factor, set the factors equal to 0, solve for x. Behavior at each x-intercept depends on the factor's multiplicity. Which is the number of times the factor appears in the factored form of the polynomial. So for example, this one, each factor only appeared 1 time. So each factor has multiplicity 1. But you could have something like x plus 1 squared. After you factored it, maybe you have x plus 1 squared. So then that factor would have multiplicity 2. You can have multiplicity 3, multiplicity 4. You can have any multiplicity that you want. So let's see what happens, how the line is going to behave at those x-intercepts depending on the multiplicity. So for the factored form, the factored polynomial, f of x equals x minus a to the power of p. So this factor has multiplicity p. The x-intercepts will behave differently depending on p. So if p equals 1, then you're just going to have a straight line. You're just going to have, so if the multiplicity is 1 on that factor, it's just going to go straight through that point. No problem. Just straight through that point. And of course, that would be A. The x-intercept would be A there. So this is what multiplicity 1 looks like, if it just goes straight through that point. Now, if the x-intercept has multiplicity 2, it's actually going to bounce off that point. It's not going to go through the point. It's going to touch it, turn right back around, and go back up. So that's multiplicity 2. Multiplicity 3, so if this exponent here were a 3, x minus a to the power of 3, it's still going to go through the point, but it's going to flatten a little. It's not going to go straight through it. It'll look something more like that, kind of like the cubic function. So it's going to bend at the x-intercept if the multiplicity is 3. And that pattern is going to continue. So if your multiplicity is even, it's always going to bounce off. So even multiplicity will always bounce. It's going to just touch that point and turn around. Odd will always cross. Although the larger odd numbers you get, the more flat it's going to be at that point, the more curved it's going to be at that point, versus just a 1 there, multiplicity of 1, just goes straight through. It has no reaction to that point at all. It just goes straight through. All right, so let's identify the zeros and their multiplicities. So first 0 I see right here is at -3. So x equals -3. And it bounces, so that tells me the multiplicity is even. Let's say it's 2. We're just going to go with 1, 2, or 3 on these. So -3 multiplicity 2. The second one I see is here at -1. X equals -1. It just goes straight through that point, so that's going to be multiplicity 1. The next x-intercept is at 4. And that one you can clearly see that it bends there. Now, I don't know if the exponent, if the multiplicity is 3 or 5 or 7, but I'm just going to go with 3. I know that it's odd because it's going through, and I know it's not 1 because it's not going straight through. It bends there. It curves right there. So multiplicity is not going to be 1. So we'll say 3. So again, it's going to bounce. If it bounces, it's even. So multiplicity 2. If it goes straight through, it has multiplicity 1. If it goes through but it bends, then it's odd but not 1. So multiplicity 3 is what we will assume.